So chapter 5, we're starting to get more and more into the nitty-gritty of research methods. So we talked about experimental versus non-experimental design, independent versus dependent variables. We talked about correlation, which we'll talk about even more today. But now we're actually thinking about the accuracy of our measures. So we can focus on just one topic if we want to. So we've talked quite a bit about depression, how it's related to exercise. But maybe we can just focus on depression itself, because we can use that concept throughout this discussion of reliability and validity to kind of make sense of these concepts. So reliability is our methodological definition of reliability is very close to what, I guess the colloquial definition is and what you understand reliability to be. Really, it's about how consistent things are over different measurements. So really, we're taking multiple measurements of things. And we talk about taking measurements of the same thing at multiple time points. We talk about trying to take measurements of the same thing but using multiple measurements at one time point. But really, the concept of reliability is based on taking multiple measurements. Oh, here's a PowerPoint slides. Yeah, no problem. Yeah, I kind of changed the schedule a little bit. So we're looking at how things are related to one another over time. So if I measure somebody's depression, at this time point, 30 minutes later, would my measurement of their depression be the same? A day later, would it be the same? Now, what if we had two different people measure my depression score? Would their estimates of my depression be the same? If somebody used that scale that I've talked about that has 50 different indicators of depression, would all of those generally say the same thing about my level of depression? That's what we're getting at with reliability. So when we take a measurement, and I kind of alluded to this yesterday, when we take a measurement of something, it's very hard to get a 100% correct measure of that. So what all measurements are composed of, and to varying levels, is true score and measurement error. So you can imagine something like body weight. So if I want to weigh myself to see if my diet's working in the morning, I'm going to use my cheapo scale that I got at CVS for 15 bucks. And I stand on it and I weigh 195. And then a minute later I stand on it again, I weigh 197. 2 minutes later I stand on it again, 193. So there's this variation around my weight that somewhere in that range is my true score. So if that was kind of the range from 193 to 197, it's probably 195, kind of in the average there. But what those measurements are showing is that there's a true score in there, but there's error around the measurement of that score. So that's what measurement error is. So that's the unreliability of a measure. So compare my $15 CVS scale, even $5 CVS scale, super cheap. It's all plastic, to a scale used by like the US Weights and Measurements Department to measure, I don't know, gold bars or something very valuable that they put a ton of time into just developing this scale to make sure it's as accurate as possible. So if I got on that scale and probably broke the law by getting on the scale, it would be 195. Every time I stand on it within a given interval of time, because my weight is going to change. But it would be very reliable. It would say the same thing over and over. Now, in this concept and in this example, even the US Department of Weights and Measures scale probably has some measurement error in it. There's probably a very small margin of error that's associated with each measurement. But getting at the true score, getting at the true underlying measure of something is very difficult. And that's when we're just talking about weight. When we're talking about something psychological, like depression, something related to maybe nutrition and sports performance, like base metabolic rate or something like that, That's something that's really hard to measure because there's a lot of variables that go into that. So for BMR, base metabolic rate, you have your height, your weight, your age, your gender, your level of activity, and you can go online and find BMR calculators, and you put in all of those things, and really you find 5 different BMR calculators, you get 5 different measures of your BMR. Now, if you go to one of our physiology labs and you get your BMR measured through like I think they're called metabolic carts, where I think they actually hook you up to a machine and you get on a treadmill and they measure your like output of breath and a bunch of other things I don't really know. But what ends up happening is they have a much cleaner measure of your BMR that takes a lot of the potential confounding variables, potential sources of error out of the measurement. So really the idea is cheap ways to measure things usually contain more error. More expensive, more precise ways to measure things are closer to the truer score, but they still contain some measurement error. Now, we talked about reliability being based on more than one measurement of something over time. One way that reliability is assessed, and in a lot of different ways, is that correlation coefficient we talked about. So how strongly things are related with one another. So this Pearson correlation coefficient is based on the idea that you have 2 variables. It could be 2 different variables, so height and weight. It could be your weight at 2 different measures of time. So what it needs to be is like a numerical value. So you can't, at least for our context now, you can't look at a correlation between race and ethnicity and weight, because we'll talk about that in future chapters, how we measure things, but there's not a real numerical difference between white, black, white, Hispanic, white, Asian. Those are categorical values. They're not numerical differences between them. So the difference between 0 and 1 doesn't have any relationship to the difference between 1 and 2. So it's not on a scale. So what we're looking at is variables that are measured on a scale, usually from 0 to whatever the maximum value is, but also it could be negative. So you could calculate a correlation between Celsius, average degrees Celsius and depression, which that Celsius can have negative values, but because 1 unit change is consistent all the way across that scale, we can use it for correlation. So correlation is based on using numerical variables. Now correlation itself, we keep talking about this concept, so it's important to understand. How many have actually used correlation in other classes? So not too many. So I think that's good, because that's one of the key concepts in this class is how variables are related to one another. So correlation is a numerical value, and it's between the numbers of -1 and +1. So 0 is right in the center, and you can think of if 2 variables have no relationship with one another, so if we drew that x-y axis and it was just a straight horizontal line, the correlation would be 0. So that means no relationship. So the closer you get to the extremes, -1 and +1, that's the indication of strength of relationship. So if 2 variables are related with a correlation of +1, that means there's a perfect relationship between the 2. So as one variable increases 1 unit, the other variable increases 1 unit, or a given scale increase that's the same as the first variable. And the difference between positive and negative is a positive correlation indicates a positive linear relationship. A negative correlation indicates a negative linear relationship. So when we talked about exercise and depression, and let's say there's a perfect relationship between number of minutes exercised a day and your depression score, that would have a correlation of -1, because as exercise increases 1 unit, your depression score would increase a certain amount of units consistently over that scale. Now, the positive relationship, income and education. So as education increases, income also increases. that would be a positive correlation, but it's probably not a correlation of 1. A correlation of 1 is very hard to find in actual practice. Usually a strong correlation, I think, is anything above 0.8. So that also relates to the measurement error, because if there's a random error in the measures that you're looking at, income and education, even if they're really strongly related, there's still going to be some noise around each of those. So when you try to correlate that noise, it doesn't end up being a perfect correlation. So this is a measure of scores on a test, let's say. So on maybe the total points are 120. It's a difficult test. So for the most part, people are scoring 100. Now let's say this is a test of intelligence, and we're using 2 different tests. One has been, millions of dollars has been put into this, because this is used to, I don't know, identify people who should be spies, or geniuses, and people that are central to our society advancing. So one test is very important, has been really reviewed a lot. The other is something that maybe is used in when you're trying to find somebody for a job. So you go online and you have somebody do this intelligence test, and instead of maybe 300 or 400 questions in that really accurate test, we have 15 questions that measure their intelligence. Now, if we're testing the same thing, we should have the same overall average score on the test. So that's what we see with this 100, is both of these reliable and unreliable measurements of intelligence have the same average. So we'll look at these kinds of distributions later, but this is a normal distribution, and I'm sure you've seen bell curves and that kind of thing. These are both normal distributions. Actually, the unreliable measure is more of a normal distribution, because there's really a better distribution of, I guess there's a more even distribution across the scores. But this would really be considered normal, because pretty much 50% of the observations fall on one side of the average. So the average is right in the center of one of these distributions. 50% falls on one side, 50% falls on the other. That's really one of the strongest indicators of a normal distribution. So you can see that with the reliable measure, with the really expensive measure of intelligence, there's very little variation around the average. So everybody is scoring right in between these numbers here. So there's really a tight margin of error. There's not a lot of variation. There's not a lot of error in scores. So pretty much everybody's averaging around 100. And on that reliable measure, people are scoring in between maybe, 98 and 102. And that's really tight. Where on the cheaper measurement scale, we have quite a bit more variation on the test. So people are scoring in between 85 and 115. What this shows is the average is really what we think is the true score. Everything outside of the average is what we call measurement error or random error. We call it random error because we think that it falls randomly around the mean, although most things fall around the mean and then kind of are distributed. We call them normally distributed random error because we assume that the error is distributed according to a normal distribution. We won't get into that too much, but you can see that the width of these different distributions are indicative of how much error is in the measurement. So something that has really wide tails is going to have more measurement error than something that's focused really close together. So how do we assess reliability? Like I said, we need to have at least 2 measurements, but how we have these 2 measurements can vary across different methods, different needs, and that kind of thing. So test-retest reliability is, let's say we have the same individual and we take their measure of depression, and 2 hours later we get them again and we take that measure of depression again to see if we have a reliable measurement of depression. If it's reliable, then that person should have almost exactly the same score as they had 2 hours before that. Problems with this kind of testing can be related to change in the individual over time, so maturity. You can imagine that if we were measuring intelligence in children and we wanted to measure intelligence every year, we'd have a hard time knowing if that same scale or that same test of intelligence was reliable, because that individual is naturally changing in their intelligence. So our underlying measurement intelligence, if it doesn't change with them, is not going to be reliable on that individual. You know, that makes complete sense. Now think about depression. Depression is something that has some variability in it. So if somebody measured my depression today, somebody measured my depression a week later on using the same scale, the correlation might not be that high, because maybe today I'm having a really good day, but next week I'm having a really bad one, so my depression score is high. So that individual variation can really cause problems with test-retest reliability. Also, when we talked about internal validity, that kind of artificiality of experiments that are done in labs. So unless you say we're testing depression, but in a very controlled setting in a lab and that kind of thing. So unless you're measuring depression in the same lab with the same people being like the experimenters and the testers using the same scale, if anything changes in the environment, that could also produce changes in test-retest reliability, because maybe that person's reacting to the environment somewhat. So that can be a problem. And then the maturation. So, you know, natural progression of individuals over time can cause problems for test-retest reliability, as well as just natural variation. So one day to the next, you know, that's one thing. It's hard for me to assess the reliability of my scale, because my weight actually varies from day to day based on how much I ate yesterday, how much I exercised, how much water I drank before measurement, and all that kind of stuff. So test-retest reliability can be difficult. Now, if you're testing your scale and you're using a gold block, you know, a block of gold that's maybe 50 pounds, that's not really changing. You know, at the level, I guess the atomic level, there might be some change. So if you're really trying to measure weight at that level, that could also be a problem with test-retest reliability, is just the change in matter over time. But you can imagine that, you know, if we're testing my scale with a 50-pound gold bar, it should be reliable and should be pretty much the same over time. It shouldn't change based on what's being measured, because that gold bar is going to weigh 50 pounds each time. Internal consistency reliability is we stop looking at change over time, but we start looking at how individuals or how the underlying item we're measuring is measured across a variety of things. So when I drew yesterday, and you can still kind of see it, the differences in how we measure depression. So on the left side, we have, you know, just this one indicator of depression. Here we couldn't really look at internal consistency reliability. So if we just had one measure of depression, we couldn't really look at internal consistency, because it's only one measure. We don't have anything to compare it against. But if we have different measures of depression, so, you know, how sad have you been in the past 30 days? Has your sleeping changed in the past 30 days? You know, how many days in the past 30 days could you not get out of bed? And then we put that all on one, you know, that becomes, we kind of average the relationship between these, and that becomes our indicator of depression. Then we can look at internal consistency reliability, because really we believe each of these different items, and we call them items, is indicative of the underlying measure of depression. And we would probably assume, and let's just say for the sake of our discussion, say that they are almost, you know, they're all really good measures of depression. So if somebody is depressed on a scale from 0 to 1, and let's say that, you know, I'm depressed at, you know, on that scale of 0.5, each of these would be 0.5. That would have really high internal consistency reliability, because what we do to measure internal consistency reliability is look at the correlations between those things. So the difference, test-retest reliability is looking at change over time. Internal consistency is looking at change at one point in time over multiple indicators. So ways to assess internal consistency reliability, these really rely on correlation. So the first way to do this is split half reliability. So let's say we have 100 different indicators of depression. What we would do is randomly select 50 of those questions and put them in one group. Randomly select 50 of those, I guess the other 50 would be randomly selected as well, and put those in two different groups and then measure the correlation between those values. So if there's a high correlation between those, that would say that we have high internal consistency reliability. That's only one randomization. So what we want to do is probably look at how many different combinations of these items can we have, and then assess the reliability. And that's what Cronbach's alpha does. So it's the average of all possible split half reliability coefficients. So what you would do is you would pretty much give every item 1 from 100 a number and randomly select your first set of 50 and then the other group of 50. Look at the correlation between those, and then put everybody back in the pile and then reorder that. So pretty much you can't have the same groups twice, and pretty much you would go through, and this is called like, what is it? Not factorial probability, binomial probability. I haven't taught that in a while, but really how many different combinations of those 100 items in two groups could be put together, and then you take all of those correlations and then average the correlation. Cronbach's alpha is what you'll probably use, especially if you actually ever use something to identify reliability. This is what you would do. So item total, this is, let's take those 100 measures of depression. We just take one of the measures of depression. So, how many days in the past 30 days have you been able to get out of bed? So what we would do is we would test the correlation between that and the combination of all the other values. So you can imagine that, let's say that this is that item that we're talking about. And really we think everybody loads on this underlying factor of depression. But what we would do is take it out and then see what the correlation between this item was and the kind of average of all of the other depression measures. This is cool because what you can do is look at how each item loads on a factor or loads on a scale. So, maybe this, how many days you got out of bed late, is not really related to the other measures of depression. So this helps us rule out bad indicators, bad items on a scale. So that's really, pretty helpful in being able to identify what items we want to have in our scale. And I think hopefully I've defined these terms well enough. So the items are each of those individual boxes, and that's kind of each of the items in a scale. So we call a scale the combination of all of these different items. So when we talk about depression here, we're talking about a depression scale composed of multiple items. I'll also call this a factor, and that's actually more related to the statistics of measuring these kinds of things. So when I say factor, you can think of that as scale, and just think of that as the combination of underlying items. Now, we've talked about change in one individual over time. We've talked about different measurements of the same person at one time. Now we can talk about the measurement of the same person by two different people. So a lot of times we want to have, especially in variables that are observed by individuals. So as an undergraduate, I did an undergraduate honors thesis because I was an overachiever. And I was a sociologist, so I looked at interesting, at least what I thought was interesting things. And I was really into cooking at that point. I wanted to be a chef, and I worked at a restaurant that, I still love the place, but I expressed that to my advisor. And she was a sociologist that was interested in like gender disparities. So she had me start reading about things of, how in kitchens, usually men are given the high status roles and females are given lower status roles, prep, that kind of thing, where guys are the chefs. So we came up with the idea of actually looking at how on television, because I was watching a lot of Food Network and that kind of stuff, how the funding for the shows influences depictions of gender in these televised kitchens. So I was really into, actually PBS is the one that I watched all the time, Lydia's Family Kitchen was awesome. America's Test Kitchen is still awesome. So we came up with the hypothesis that the shows funded by PBS would have more egalitarian depictions of gender in the kitchen, meaning there would be more women in roles of authority, more men in roles of, actually like being like helping female figures in the kitchen, and a lot of different ways to measure that. So we looked at, how much, was it a commercial kitchen or was it a kitchen in somebody's house, because that was kind of an idea. Is a lot of cooking shows, you'll see women cooking in their house, and a lot of cooking shows with men, they're cooking in a commercial kitchen with a bunch of like stainless steel stuff. So we came up with all of these different items to measure like gender roles in the kitchen. Now, I was really keyed up on this, and I was like, oh, I know what we're going to find. PBS is going to be more egalitarian because of the funding structure and I guess ideals of PBS. But I'm kind of a biased observer because I came up with all this. I want it to look good. I want it to get published and that kind of thing. So we had to have other people watch the same TV shows as I was watching to see if I was coding them correctly. So we had to calculate inter-rater reliability between me and two other viewers. And what I did was, I think for 2 weeks, I recorded 15-minute segments of pretty much every cooking show that was aired at the time. This was VCR days, so I had set the timer of the VCR to start in the middle of the night and that kind of thing. So in the end, it wasn't more than maybe 6 or 7 hours of 15-minute segments of these shows. But I sat there, and with my document that had all of the items, were they wearing professional outfits, or was it like a Holmesy apron kind of thing? So I made notes for each show, and then two other people that were graduate students also did that. Actually, no, they were undergraduate students at the time. But they did that, and then what we did was we looked at the correlation between the scores. So if I was coding something as, oh, this is obviously an industrial kitchen, and everybody else was saying, no, that's like a home kitchen, then we would have low inter-rater reliability because the correlation between my scores of those things and their scores of those things would be low. So this is something that's important for these kinds of things that are hard to measure, things that are observable, kind of only, and like, I guess they're perceptible by us. So that's a pretty interesting way of measuring reliability, and actually one that I've used, so I think it probably gets used a lot more than the other ones that we've talked about, split half and that kind of thing. So we've talked about change in a measure over time. Are we measuring the same thing, whether it's over time with different items, over, through different people's eyes and that kind of thing? Now, reliability is necessary to have accurate measures, but it's not necessary. No, I should say that reliability is necessary to have a valid measure. You can have a reliable measure. I'm trying to remember this. You can have a reliable measure that's not valid, but you can't have a valid measure that's not reliable. So imagine that and our book talks about using a indicator of somebody's shoe size, like a shoe measurement thing or foot measurement thing, as a measure of intelligence. So I sit down and I have unusually big feet. I sit down and somebody puts my foot in this measurement and they say, you have a size 14, so you must be really smart. Thank you. But then I go back the next day and I still have a size 14 foot. And the next day I still have a size 14 foot. So the correlation between my shoe size is 100. It's perfect. But so that means it's reliable. That would be a reliable measurement of something. Is it measuring intelligence? Not at all. So it can be reliable and we're not going to talk about validity today. We're going to save that for tomorrow. But validity is how accurate it is. So this is a really important depiction of the relationship between reliability and validity. So maybe some of you are hunters, bow hunters, and that kind of thing. I want to learn how to hunt, but I just never have. So this is a good way to think about reliability and validity. So up in the top corner here, we have something that's both unreliable and unvalid. So you can see that something that's valid hits the target. So when we're measuring intelligence, we're not using somebody's shoe size. We're measuring how well they respond to all of these indicators of intelligence. How do you measure intelligence? I don't know if you guys are sci-fi fanatics, but how do you identify something that has actually developed artificial intelligence? It's very difficult. This would be unreliable and unvalid because all of these different shots are kind of all over the place. And they're also not anywhere near the target. So that would mean that it's unreliable because the shots are really all over the board, and it's unvalid because it hasn't hit the target. Now over here we have something that's unreliable, but it's valid. So you can think if you averaged like the point where all these shots would meet, it would actually be in the center. But each shot is kind of all over the board. There's not really good marksmanship there, but that person's kind of centering in. So that's showing that they're probably looking at the target, and they're probably their sight is aimed well, but they just don't have whatever skills, reflexes necessary to hit the target. They're going for what's right, but they're having difficulty doing that, and things are just randomly distributed across the board. Now, here we have something that is reliable because all of those shots have a very small grouping. So, this is looking at my shoe size as a measure of intelligence. So my shoe size is never going to change, but it's not anywhere near what we're actually trying to measure as intelligence. Now, if something's reliable and valid, we see that it has a really tight grouping, and it's also right on the mark. So we have something that doesn't vary from measurement to measurement, and what we're actually trying to measure, we're measuring. We're actually getting to the underlying concept beneath that. So we're actually measuring intelligence by maybe doing a GRE or having these kinds of self-awareness tests that they use for artificial intelligence. So, like I said, something can be reliable and not valid. Maybe I shouldn't keep going on that because I don't know if I'm explaining that concept right. But really, we need measures that are both reliable and valid. So, we probably think, just as kind of untrained scientists, that we want things to be valid. That's the most important thing, is that we're actually measuring what we want to be measuring. So when we're measuring depression, we want to be measuring depression, not something else like intelligence or anxiety or different kinds of concepts. But in actuality, we need it to be reliable and valid, because if our measure has a lot of error in it, what's going to happen is, even if we're actually getting at the underlying concept of intelligence, we're not going to really have a lot of confidence in our results, because even if we're looking at the same person's intelligence from day 1 to day 10, and each of these represent a different measure of that intelligence, it's going to be hard for us to say. I should say that there's a lot of variability in the measurement. So when that comes to looking at how intelligence relates with maybe depression or something, what happens is we can't get a strong correlation, because, like I said, if you're correlating things with a lot of error, they're not going to be strong correlations. So we need something that's both reliable and valid before we can start looking at how it's related to these other kinds of things. Start my recording. So yesterday we talked about reliability and making sure a measure is consistent over time, whether it's, I should say consistent, a measure is consistent over different measurements. So it can be consistent over time. So looking at how a measure is correlated with itself at time 1 versus time 2. You can also have different measures of the same construct and see how those are correlated and different ways to look at reliability that way. And then we ended with the targets and talking about the relationship between reliability and validity. So really we want to measure that's both reliable and valid. So when we talk about validity, we're talking about the actual accuracy of the measure. So is your scale measuring the underlying construct that you're interested in? So if I'm interested in measuring depression, are you actually measuring depression, or are you maybe measuring something else that's closer to anxiety or maybe bipolar disorder, these other sorts of psychological disorders that can be related to depression but are not really depression. So we want to measure that really gets at what we're focusing on. So when we talk about different ways to measure depression, one was talking about like a self-report. So I just ask somebody, how depressed do you think you are? That actually has been shown to be a pretty good indicator of the person's underlying measure or levels of depression. But because individuals have, they vary over time, there might be error in that measurement. So the more error there is, the less valid it's going to be, because the less kind of on that target it's going to be. So if I ask them multiple questions about depression and then look at how all of those combine to predict depression, we're hoping that would be more valid. It would be closer to what that under conceptual idea of depression really means. So with validity, so trying to assess how well are we measuring what we want to measure, we have different ways of assessing that. So really it's about assessing construct validity. So remember, construct validity is how we set up our questions and set up our measurements to get at that underlying construct. So when we're assessing the construct validity of a question or a set of questions, we need to use really two different kinds of tools to assess the validity. One of them is using these kind of subjective tools. So kind of making the value judgment, is it valid or not? There's two different ways to do that. And then we also use criterion-related tools to measure validity. So that's actually using an outside source to test it against. So seeing how things outside of the scale relate to it. So we'll talk about these subjective ones first. The easiest and I think the most straightforward way to assess criterion validity is using face validity. So if I ask you to, maybe 10 questions about depression, you could look at each of those questions and, are they good questions related to depression? Am I asking about sadness? Am I, asking about loss of appetite and things that go along with depression? Or am I asking things about, maybe social anxiety? So am I asking things about when you get in groups, do you feel uncomfortable around other people, and things that aren't really related to depression. So you should be able to look at a question or a set of questions, a set of items, and a scale, and just say, overall, does it make sense? Am I getting close to what I want to be measuring? So that's what face validity would be. Now, if you're not trained in a certain subject, it's probably not useful for you to say, does it have face validity? So if we're looking at, something very specific and maybe hard to conceptualize, not depression, it's something we've talked about, but maybe bipolar disorder. Hopefully none of you have experienced that, but like the underlying behaviors that are associated with that are really quite varying. So if I was to give you a battery of, that's even a tested, validated battery of bipolar disorder, you might look at it and say, I don't know, because all of these things are contradictory. There's really high highs, really low lows, and that kind of thing. But if I gave it to an expert in bipolar disorder, somebody that works with people with bipolar disorder, then it would be a lot more sound for them to assess the face validity because they've been trained in it, they know it. So face validity is really not that valuable unless somebody that really knows the topic is the one judging that. Now, content validity, this is subjective again, it's somebody's opinion, but we're saying do all of the items in this scale of depression. So now we talk about criterion related concepts of validity. So here we have, predictive validity to begin with, and predictive validity is where we start to use something external to the scale to actually have it to identify its validity. So this would be when we talk about depression a lot, but let's talk about work ethic or something. We create a scale that we think measures people's work ethics. So we've developed that. We think it has good face and content validity. But now we have to see if it actually predicts work ethic. So we want to be able to say, let's test everybody in the class on our work ethic scale, and then maybe we use grades as the outcome and say, okay, people that scored high on the work ethic scale should have better outcomes on grades. So it's predicting a future outcome that it should be. So with depression, a depression scale should predict actual clinical diagnosis of depression. And that's kind of a good example our book talks about. So it predicts an outcome in the future that it should. Now, concurrent and convergent validity, these are a little, originally when I did this lecture for the first time in the spring, I had a really hard time differentiating these. So I've changed the definitions here a little bit from how our book talks about them. So concurrent validity is actually being able to look at a group of people and say, based on the characteristics of those people, you should be able to differentiate between them. So if we get so if I just go to maybe, the Arizona State Mental Hospital, and there's people that have really severe depression, and then there's people that are there for other kinds of disorders, I should be able to use my depression scale to separate those groups. So I should be able to use my depression scale to give everybody those questions, not even look at them, not interact with them, have no idea about what that individual is or acts like outside of their responses to the scale. And then I should be able to pretty much accurately judge which ones are depressed and which aren't. So you should be able to differentiate between groups with your item. So the book talked about using a social, social anxiety scale, and then you should be able to go to maybe a telemarketing firm where some people have to make cold calls and some don't, and they kind of get to judge which ones they want to do based upon their own levels of social anxiety. So your assessment of social anxiety should generally match those people's self-selection into different groups. And that's that idea, is you're differentiating between groups that naturally exist. Now, convergent validity, this is that there's other measures usually. There's multiple different operationalizations of depression, so self-rated depression. The CESD is a really popular depression scale, but there's a lot of them out there. So your new depression scale, you've added new items, that you think are related to maybe, mobile phone use, just internet use, modern kind of things. But you want to say that I'm still measuring depression. How do I show that? I go and actually find the CESD score. I forgot what that acronym means. I wish I could tell you. But what I would do is measure individuals on the two different scales. And then what I would do is look at how well those correlate. So if my new depression scale has a high correlation with the CESD, which has been very well proven to be a good measure of depression, then I have convergent validity because it's all converging on the same concept, and this is related to high correlation between measures. Now, discriminant validity, this is being able to differentiate between people and groups that it should. So, on our depression scale, people that are high on our depression scale necessarily wouldn't be high on something like maybe the work ethic scale. Maybe those things aren't related at all. So if we're starting to see that our scale has high depression and then a lot of other things we don't think are related are also high, maybe we're not really just measuring depression, we're measuring all of these other weird things, and we don't have a very narrow conceptualization of depression. So that's what discriminant validity is being able to be associated with what it should while not being associated with other things. So, I guess like you could think of like a happiness scale probably wouldn't be related to like a work ethics scale. It's just those things, while there may be some relationship, really they shouldn't be. So this is kind of looking for low correlations between things. So convergent validity, you want a high correlation between things to support that you're measuring what you want to be, where discriminant validity is you have low correlations because yours is not related to these other things it really shouldn't be. So all of these, like I've said, are criteria related because it's kind of outside. We're using something external to judge the validity of our measures. So reactivity of measures, this kind of relates to what we've talked about in experimental design. So we've talked about how experimental designs can be artificial and you can't have good external validity when you have a really well-controlled lab test. So reactivity is when a person knows they're being measured somehow and they change because of it. So let's say I go to my psychologist and I do the depression scale and I actually feel depressed, so I want to give them the most honest representation of my feelings so they can diagnose me and treat me as they need to. But let's say we do the depression scale in a public forum. So the psychologist comes in front of everybody, they ask me all of these questions. And I know that the social, there's, I guess, the social desirability around being non-depressed is going to make me change the way that I respond. Now, this isn't directly reactivity because that's a little bit more like, I guess, a social aspect of it. But really, imagine that just even like levels of happiness, So if you're being measured on happiness and you think it's good to be happy, you're going to act happier when you're being measured. So how do you really identify somebody's happiness without them knowing that they're being measured? And this is where some deception comes in and I guess creativity. And how do you actually record what you're measuring if you're worried about the reactivity in it? So our book talks about like we want to know which artworks are the most liked at a given museum or something like that. And let's say that there's some really big, Picasso, Van Gogh, like really big names. But then there's also some, I don't know, like kind of no-name people, but their art is really fun and expressive and everybody enjoys it. So if you asked people leaving, which were your favorite? Did you like the Michelangelo or the Bishop? They would say, oh, the Michelangelo, because that's the important one. I want to look smart and I want to look cultured. So I'm going to say the Michelangelo, even though maybe they really liked my painting, which was like finger painting. The way that these researchers assessed which paintings were the favorite was just by the wear on the floor around the painting. So they actually looked at how much paint was taken off the tiles or how much, I guess, how the thickness of the tiles were and that kind of thing to see which were the favorite. So that's kind of a creative way of saying we want to measure what people are really looking at without them knowing. So that's kind of a fun, easy way to do it. But a lot of the times, especially in experiments, we use deception. People don't know that they're in the control group, that they're getting a sugar pill versus, this new blood pressure medicine and that kind of thing. So this is something that is really difficult to take into account. I think in surveys, one way that we take it into account is we just assume everybody has the same reactivity to the question. So we don't try to dupe them into not measuring it. We just have to assume that error that's caused by the reactivity is consistent across people. So we can factor that out because everybody's reactive to that same question. Now in experiments, what we do is usually we deceive the person, give them a sugar pill. We give they go into a classroom where they're not being treated. They're not getting the new math test or the new math training and that kind of thing. So we actually deceive people. I alluded to this a few times already, but now that we know how to address reliability and validity, we need to talk more about the underlying way that we measure things. So we've talked about self-reported depression, and even in that, so just imagine self-report depression. I ask you a question about your depression. There's different ways that I can ask that question, and I can get different kinds of responses that give me differentiating abilities to use statistical tests to look at differences between people and that kind of thing. So we need to know how we define the scale on which we're measuring. So the first is nominal. So this is categorical. So if I wanted to do this depression, just one question self-report, I would say, are you depressed? Yes or no. So we have two categories, yes or no. There's not a real numerical difference. It's just a category. You're in one or the other. Now, race is a categorical variable that is, I think a really good indication of something that's nominal, because we have white, black, Hispanic, American Indian, Asian, other, and we have 5 or 6 different groups for race. And we could number those, and we would have to. So say we're making a spreadsheet and we're recording everybody's race and ethnicity. Rather than writing it out, I want to be able to use things with numerical properties. So I give, white 1, black 2, Hispanic 3, American Indian 4, Asian 5, other 6. So now I have a scale that goes from 1 to 6, but there's no real meaning in the order of that. So, there's not a real numerical difference between white and American Indian. If you subtracted those numbers, you'd have like a 3, but what does that mean? It doesn't really have any meaning. So that's what a nominal is, and I think you can associate that word with names. So that's kind of what it is. It's just naming. It's just putting things into categories. Ordinal scales are similar to categories, so they're actually they're ordered categories. So instead of having white, black, Hispanic, now we get into talking about things that are ranked lowest to highest. So Yelp ratings is one example I like to use. So we have 4 stars, and you can have 3.5 stars, 4 stars, and that kind of thing. The difference between 1 star and 2 star, it's not really quantifiable. Maybe it's not the same as the difference between 3 and 4 stars. So you can imagine that, I guess, people that are always on Yelp reviewing, I don't know. Let's just assume that they like tearing things apart. They're negative people, so everything's usually 1, 2, maybe 2.5. So in that case, there's a lot more observation and a lot more, I guess, assessment of those items that are 1 star, 2 star, and there's not as much between 3 star and 4 star. So if you look at the difference between 1 star and 2 star, because there's so many observations of it, it might actually be more meaningful because more people have put their opinions into it. Where the difference between 3 and 4 star, if there's only 5 or 6 people that have made those differentiations, then the differences don't make as much sense. So ordinal is rank ordered. There's not numerical values that can be really compared. So you kind of get close to saying, well, I could look at the difference between 4 stars and 2 stars, and that's 2 stars. But you'll see when we talk about interval that it's still very basic. It's not something that we can use to do a lot of math with. And that's, I think, a good way to think about this is starting with numerical and going down, we go from the general to the more specific. So once we're at ratio, we can do pretty much any mathematical operation with a ratio level variable. But with nominal, we can't do a lot of stuff. Interval scale. So this is like temperature. So an interval scale is we have equal units between numbers. So the difference between 1 and 2 is the same difference between 99 and 100. It's the same interval difference. So the difference between 1 and 10 is the same difference between 11 and 20. So there we have one thing that differentiates, and I think these are hard to separate sometimes, and in practice it's almost not necessary, between interval and ratio is interval has no true 0 point. So 0 is arbitrarily set on the scale somewhere, and this is when we have things like temperature. So we have negative degrees, negative degrees Celsius, negative degrees Fahrenheit. So there's not a true 0 point. Where with ratio, and the reason we differentiate and the reason we call ratio is because if we have a true 0, then we can actually calculate ratios of things, because you can't calculate a ratio with a negative number. So if you have a negative number in the numerator or a negative number in the denominator, it doesn't become a ratio. You can't calculate that. So a ratio only differs from interval in that it has a true 0. So things like, you can always just say, like, when I ask you a question about a variable, is it interval or ratio? Think about the variable, and could it have negative values? If so, then it would be interval, and it also has these numerical properties. Now, if it can't have anything less than 0, it would be a ratio. So things like weight, age, height, and that kind of thing. So this is I was hungry this morning and got onto Yelp and wanted to know what the good Chinese places were. So this is that ordinal scale at work, and it gives me a pretty good idea of the I guess the distribution of each of these. So we would say here on average, these 15 reviewers had a 3-star review of Imperial Garden Chinese restaurant, 4 stars for Wok and Roll. That gives us some numerical indication. We could actually do some stuff. We could probably even do regression with this. What we have to do is make assumptions about the distribution. So we'd have to end up saying, does this ordinal scale have properties similar to interval and ratio scales? If so, then we can start doing correlation. We can do regression. So we could look at the correlation between maybe the number of times a given individual has reviewed and their review of Imperial Chinese Garden. We could probably do that as long as we assume that this is normally distributed. It's another big part of interval and ratio scales is we assume that they have normal distributions. A lot of times they don't, but what we want to see is that bell curve. We want to think that most people would choose or be around the average. So height, most people fall around an average height, so I think for men it's probably 69, 70 inches tall. But then there's a kind of normal distribution of people that are smaller, and it's decreasing the smaller you get, and there's kind of a normal tailing off of tall people, and there's fewer people the taller you get. So that's a big part of interval and ratio scales as well, is that they should be normally distributed. Now, with these kind of ordinal scales, sometimes they're not, and that's where a lot of work is put into measuring how, or I guess assessing how we can talk about ordinal scales in a statistical context. With the ordinal scales, and these are Likert scales, or ordinal scales, and you've seen these all the time. So on a scale of 1 to 5, was Nick's class very good, good, mediocre, bad, very bad? Like that would be an ordinal scale, and those are a lot of what's composed of surveys. Now what people do is almost blindly they take that information and start looking at correlations between how good my class was and maybe how many years of training and all that kind of stuff. So it's something that you need to be aware of, and you should probably be careful of doing, and just keep in mind when we're talking about our in-class assignments and our exam. So I've talked about some of this importance of measurement scales. The basic idea here is you want to collect as much information as possible. So with race, you can only do a nominal scale. I think I was calling nominal ordinal on the last slide. But with a nominal scale, you can only get 0, 1, 2, 3, and those represent categories. But with our depression scale, let's go back. And so we have one measure, one chance to ask somebody a question about depression. So I go and, I guess in a non-reactive setting, I ask everybody in the class, are you depressed? Yes or no? So that becomes a nominal 2-category variable. all I can look at is the probability of being depressed versus not depressed. So pretty much what percent of people I ask are depressed. Now, what if I asked you on a, I guess on a ratio scale, on a scale from 0 to 100, tell me how depressed you feel. Tell me your depression on the scale from 0 to 100. That would give me a lot more information, and it would give you a lot more flexibility to say, I'm a little bit depressed. I'm, generally not depressed. I'm on a scale of 0 to 100. I'm a 20 for the most part. On a scale from 0 to 100, I'm a, 75. That's going to give me a lot more information, because then I can look at the distributions, and I would assume that there's an average. So we would, I guess I could hypothesize that the average would be 50, and then there would be a normal distribution of people following around that. So most people feel pretty normal, but then there's some people that are highly depressed, some that are not depressed at all. But there would be very few people at the very tails of that having extremely high depression and extremely low depression. So we always want to collect as much information as possible in our scales. So if possible, ask ratio. If not, try to ask interval. Usually the difference is between either interval and ratio and ordinal. So if you can, ask interval ratio rather than ordinal. If you can, ask ordinal as compared to nominal, because those categories give us very little, I guess, substance to deal with.